Good morning, all of you. Today we are seeing the concept of Bragg's law from X-ray topic. In this diagram, there is two eminent personalities are Bragg and his son. Both of us get a Nobel Prize for the uh, discovery of Bragg's law equation in 1915. We will move towards the next slide. This is the introduction of Bragg's law. In that, it is a special case of Lewis diffraction and gives the angle of incidence and incoherent scattering from crystal lattice. According to this law, when X-ray is incident on a crystal surface, then it will reflect black with a same angle of scattering. This is the general instruction of Bragg's law. We will move towards a next slide. Okay, in this picture we have plotted some points with a periodic manner. Each point represent as a lattice, and the distance between the two consecutive points is nothing but the interplanar distance between the two atomic points. This arrow represents the incidence light. It means that whenever we incidence a beam of X-ray, then it falls on a lattice. Okay, this diagram clearly shows us. Next, we move towards a next point. Okay, this diagram clearly represents the X-ray diffraction phenomena. Here we taken a one sample, which is represented by the greenish color at middle of diagram. With the help of red arrow, it represents the incidence beam, and from the right hand side the red arrow represents the transmitted beam. It means that whenever we take any type of sample, then the incidence beam of monochromatic X-ray beam falls on a sample, and due to this it will transmit some of the portion of incidence beam and also diffracted or reflect in all possible direction of some portion of incidence beam. Okay, this diagram clearly shows us the X-ray diffraction. In this, we have taken a sample as a nickel crystal. Nickel crystal consists of regular arrangements of lattice points which are separated from equally distributed. Thus, the nickel acts as a good thermal conductivity and also the good electrical conductivity. It has higher melting points and boiling point, so it can bear the high energy particles and also responsible for the diffraction and transmission. That's why we have taken such a type of crystal. Okay, these are the properties of nickel crystal. Here the sample, whenever we incidence a monochromatic beam of X-ray light, then it will partially transmitted and partially diffracted in all possible direction. In the grayish color sample, there are some fine lines are drawn in the sample that represents the interplanar spacing. Okay, we will move towards. See here, the black dotted points represents the lattices and the arrow represents the incidence beam of monochromatic X-ray beam. When it interacts with a lattice point, then it will diffract in all possible direction as like in a circular manner for a single lattice points. Okay, in the diagram we have shown for all lattice points the diffraction will be taken in all possible direction, somewhere the closer, somewhere the some distances in between the diffraction, and okay, it means that it is not uniform in all possible direction. The line joining the lattice points are called the interplanar lines, and the distance between the two interplanar lines is represented by the small letter d, which is called as the interplanar spacing between the two lattice point, and which is a constant throughout the atom. Here is black arrow represents the incidence beam, and the bluish light bluish color represent the reflected light from the surface. We know that the laws of reflection. Here is one plane represented by green color. The dotted line represent the normal which is drawn to the surface. Whenever any radiation incidence on a surface, then it makes an angle with surface known as a theta, called as the angle of incidence. Then whenever it gets a reflect from the plane, the angle is known as a theta, called as the angle of reflection. So X-ray diffraction is nothing but your reflection from the set of crystal lattice plane. It is clearly mentioned here. Look this diagram carefully. In this diagram we have clearly told us that the n lambda is equal to 2d sine theta is called as a Bragg's law equation, where lambda represents the incidence beam of wavelength, d represents the interplanar spacing between the two lattice points, theta represents the angle of diffraction, and hence from this equation we have calculated the wavelength of monochromatic X-ray beam with the help of angle of diffraction and interplanar spacing, which is constant. Thank you so much. Thank you so much.